Hello everyone, I'm Akhil Reddy Jarkupalli. I have chosen the topic a computer vision pipeline, automatic large scale inventory tracking. So basically in this presentation we're gonna see like how tracking will be done for various vehicle parts. Author took an example of Mercedes-Benz US International. They have been storing their spare parts in their own logistics center, and we're gonna see like how they use the methodology in it, and like they've been using both labels like information labels and bay location labels. So information labels are like attached on front of the storage bin, like there will be located like on blue and black bins, and they have separate barcodes, whereas the other labels are on the storage racks. It should be like on the orange one, you can see in the next picture. For an effective pipeline tracking, they have been using like 5-step solution. It comprises of like label localization and label pre-processing, data recognition, information classification, and database integration. We can see in depth in the next slides. Classic computer vision techniques, we're gonna see 5 of them in it. Initially, grayscaling. It converts like a 3-channel image to a single channel grayscale image, and then comes to Gaussian blurring. By applying Gaussian function, it to an image to like smooth the output or to blur it. And when it comes to Otsu's thresholding mask, it determines like a most effective pixel. We can say it's as a clarity for an image to get like a black and white to a color one. And then comes to erosion and dilation. It's a noise reduction technique that involves layers of counters, and they can reconstruct them itself. And finally, filtration and detecting counter boxes. It considers like large or extreme for the use case, and then it generates a bound like a rectangle on those counters. This is a final overview of the pipeline tracking. We can see like step-by-step procedure on. So from the coming slides we can have the pictures there. We can easily see like how the localization is done, like labeling, and then how it processes, and the data on the product, and then how they're gonna take the information, and then how gonna generate into the database. This is a sample image of a storage rack where we can see the barcode on the rack. So labeling is done for every product to track it easily by scanning the barcode. So they're gonna make sure for every product to check in it, like where to check the current status of the product, or like where it's gonna be processing or any information regarding the product. This object detection, we're gonna use label localization, and it's well used in the machine learning. And we use a popular dataset annotation in it. It's called Label LMG, and it is an open source tool which allows like standard bounding box annotation for the entire dataset. And then from these we're gonna use like single pass through networks, because it needs to identify the objects in it, and we're gonna use a strategy called transfer learning. It is only trained for one task, and that knowledge is transferred into another applied domain. So we can see in the first picture it like identifies the racks or else the barcodes on the rack, and then we're gonna have the clear output with the bounding boxes with the picture on it. We're gonna use the YOLO. It has the idea of like dividing input images into a grid and using anchor boxes, so that like it identifies each detected object, where we can see like green boxes in the image. In classical pre-processing, we're gonna use like 2 different transformations. They are canny edge detection and Hough transformation. So the canny edge detection is like a classical CV technique. It uses multi-stage algorithm to detect and outline edges in an image, Whereas how transformation uses edges to find angles of edges that like current image contains, and it corrects overall image orientation through a small rotation. And by observing the two images of like before pre-processing and after classical pre-processing, we can identify the difference between them. Like I may say the second image is much clearer than the first image. So they are used like three algorithms for the object detection, that's classical CV and MobileNet and YOLO. They have like achieved percentage and the FPS, where we can see in this table. For image resolution, we're gonna check with the three different types. They are Laplacian pyramid super resolution network, and efficient subpixel convolutional neural network, and fast super resolution convolution neural network. We have seen their performance by observing like the images in the above, like A, B, C, D, and we got like LaPSRN as the high performance with the size and the average time, and then when compared to others they have like less size and the performance is less when compared to the LaPSRN. Before the final overview, we have two different types. They are barcode reading libraries. It just reads the barcodes and then it like gives a certain library for the certain barcode. And then it has like text box detection and text detection, so it detects the barcode and the text on it. And then after finally it includes the database integration, where like all the related information is sent to the final stage, where we can see in the picture like object detection is done in the label detection, and then the optical character recognition, and then the info classification. We have used the divider algorithm, like we have used three different types for the resolution type. After finishing the all stages, they're gonna gather some information, then they're gonna use some classification algorithm. It like specifies specific parts for the label inventory and the location labels, and it creates some data correspondence like between the pins and label. And then they have like perform this operation for the location label for every process for an image, and then they're gonna classify bins to their certain location. So the paper is solving like how all the large scale industries use the physical raw materials, and like the for inventory management they use like how they gonna face problems with the raw materials and goods, and then about the customer satisfaction like by the delay and the images damages and like image blur images. And then this paper like it gives like effective inventory management, where we can achieve in good results and manage inventory in the stores, the warehouses too, that gonna like find out and locate the items easily by the barcode detection and everything. So it also includes artificial intelligence like for the photos, videos and the images to get the information and to track it. And initially we have used like the machine learning too. The authors displayed the tracking thing in an easy manner, so everyone can understand by following all of them. The topics included in it like start from the abstract, introduction, methodology, and the five-step cycle, and then finally the integration, conclusion, and then the related work, how they followed and how they achieved finally, and how it worked effectively. And by the images we can clearly understand the differences between like each process, like how gonna they achieve it for the next one, and the improvement we can see in every image. In my point of view, authors conducted the experiment by following a sequential order. Like they identified the business problem what like Mercedes is facing, and they defined the like success criteria, like how we can achieve that, like what happens if we achieve, like what are the advantages of achieving it, and the appropriate computer vision technique we have seen it, And then initially on the label localization we have like collecting a label, training and test images, and the training model, and finally deploying and testing by different algorithms, and iterating the solution. Results. Initially we have the clear overview of the inventory by following all the sequential process, which includes label processing and localization, data recognition, information classification and database integration. Like processing every single step, then it will make easy for every management in the companies. And then by observing the YOLO model, which was like highest possible accuracy, and the object like I'm sorry, and the object detection algorithm is trained on the darknet backbone and uses path aggregation network, and it has like, and finally we got like CV techniques using a multi-stage algorithm to detect and outline edges for the simple processing. From my point of view, I have like suggestion like by giving the accurate images which are not cluttered to ensure the results were accurate, so we can have the assumptions and the conclusions much more clear for the accurate images. A reference for the presentation. Thank you everyone. If you have any questions, please let me know in the discussion section.